This is the next section of the Year 9 Making Electricity Work module, and this small part is on parallel circuits and short circuits. Now, we've talked already about series circuits, and series circuits are where all the components in the circuit are found in one continuous loop. In a parallel circuit, when the current comes from the battery, from the positive part of the battery, and goes around the circuit, it will eventually come to a point where it has a decision to make. Does it go this way, and does it go this way? And so what actually happens is that the current splits into two, and a certain amount goes through each branch. If each of the bulbs are identical and they have the same resistance, then the current splits up equally. When it gets back over to B here again, then it joins up again, and you'll have the same amount of current after B as you did before you had at A there, before it split up at A. So the current in the main part of the circuit is equal to the sum of the current. If you added up the currents through each of those branches, then those two would add up to give you the current in the main circuit. So really what a parallel circuit is that means there's more than one path for the current to flow around the circuit. And you can see, I'll just repeat that again. If it comes from the battery and gets to A, it can either go through the top bulb or the bottom one. It rejoins again at B. So any circuit, even though the two lines may not be drawn in parallel, and I'll show you another one here. If you had something like this, that's also a parallel circuit, even though the two lines aren't parallel to each other. And the reason it is because when you get to there, you can see the current can either go through this bulb or down round through this one, and it will rejoin again down at the bottom here. So that's also a parallel circuit. So if you were to measure current in a parallel circuit, and you did this in class, you place the ammeter in turn at different positions. So there's the current in the main part of the circuit before the split, and I'll just do a wee dot at the split, over here and over here. And then you would take out a link, put in your ammeter, measure the current, replace your link, take out a link here beside the first bulb and measure your current, replace it, take out a link here at your second bulb, replace it, and do it again over here after they've joined together again. And you'll find that if you record the ammeter readings in the table, if they split 2 amps and 2 amps, and I'm just making these numbers up, if I put them into the table 2 and 2, then that means before they split, A1 had to be 4 amps, and after they join together again, A4 also has to be 4 amps as well. So for a parallel circuit, the current that leaves is the same as the current that returns. The current doesn't get used up by the circuit. The current is the flow of electrons. It's just the energy that they have gets used up as they move around the circuit. So we're saying that the currents in the main parts of the circuit before the split and after the join up are the same, these two here. And then we're also saying in the branches that the current splits up to go through the two branches, and if you add those two currents up, A2 and A3, you'll get A1, which was the current before the split, or you will get A4, which is the current after the join up. If the bulbs are identical, then the current will split up evenly or equally. And this is the important one. If the bulbs are not identical, then the current will not split evenly. And I'm just going to show you a wee example of that in the next slide. So the next slide just shows you a parallel circuit, and I'm going to write down values here. I'm going to say that this is 5 amps and this one here is 2 amps. Therefore, the current before the split has to be the sum of the two branches, and therefore the current before the split must then be 5 plus 2 is 7 amps. Write that in yellow. And then the current after the join up must also be 7 amps. And it's come back towards the battery again. The reason that the current would split unevenly would be if those two bulbs had different resistance. Now, you have to think about the fact that resistance limits the flow of current. So you can see there's far more current in the top one than the bottom one. and that means that the top one has much less resistance. So the smaller resistance, in this case it's our top bulb, allows more current through. I'll just move that up so you can see it. Allows more current to flow. So in other words, from what I've drawn there, this bottom one is the one with more resistance because it only allows 2 amps of current to flow through it, but this one allows 5 amps to flow through it. Okay, short circuits. A short circuit is a circuit which allows current to flow through the easiest path. Now, this is a circuit here where you have got a cell, current's flowing round here and gets round here. Now, when the switch is open here, the current, it can't go through this part because it's broken. It just continues on round the cell and it or on round the circuit, and it lights the bulb. But if you close your switch here, and I'll just draw that in here, if you close the switch, then you have a situation where you've got either a big wide bit of metal in the switch for the current to go through, or a wee tiny thin filament like that there in the bulb to get through. And so given its choice, the current is going to go by the easiest route, and the easiest route is down along the big wide path and back to the battery again. If you can imagine that somebody asked you to run on a big wide road or run along a tightrope, you're of course going to find it much easier to run along a big wide road. And that's what current does too. If it sees a big wide conductor, it's far easier for it to do that, and it takes the easiest route. So instead of calling this short circuit, somebody should have named it easy circuit. And that's the reason why when you see a circuit and you see a switch connected in parallel with a bulb, watch out. The question will probably be something to do with a short circuit. And when you close that switch in parallel with the lamp won't light, the current will go through the switch instead.